A proportion is a statement that two ratios are equal. So when I write 1/2 equals 4/8, these are proportions. They are equal to each other. When we ask, are these proportional? That means, are they equal? Well, one way to see if they are equal, we go back to what we did in chapter 2. You're trying to find a common denominator, and by knowing that, you can tell if they are equal or not. Well, what's the LCD for these? 8. So if you change that to 8, the one on the right, I don't have to touch it. The one on the left, I have to multiply it by what?
4.
By 4. And that'll be what? 4/8. Are they the same?
Yes.
Are they proportional?
Yes.
Yes, they are. Now, a lot of people don't want to find a common denominator for them. So what's the other approach? What's the alternative approach to that?
Simplify.
I can simplify. You're right. I could simplify. I like that answer. So option 2, I can simplify. By 4, this is what? 1 by 4, this is 2.
Can you cross multiply?
Up, I wasn't going that direction. I like the other option. 1/2 equals 4/8. Another way of doing it, if you don't like this or this, is cross multiply. You go 1 times 8, 8, and you put it under the top number. Notice the 1 is the top, 8 is the bottom. The answer goes where the top number is. 2 times 4, 8, and the top number is right there. So are they equal to each other? Are they proportional? 3 different ways to prove these are proportional to each other. The problem is, in a few minutes,
Will
We're
they
go-
all give you the right answer?
sure, either method. But here's what's going to happen soon, where this method you can use it or you can use that one, these two, because I'm going to say to you what value for x will make them proportional, will make them equal. So for example, I might give you this problem. 3/5. I'll make it first obvious, 15. What value I can use for x that will make this one equal to this? And the answer is 9. And the way you found the answer, you go, wait a minute, I see it. If you multiply the 5 by 3, you get what? 15. So all you got to do, multiply the top by 3. So now you'll have what? 9/15 equals x/15. If you want these two to be equal, the bottom is the same. The only way they'll be equal if the top is the same. I said perfect. Let me just modify just a little bit that problem. Now I have no idea what to multiply the 5 by to make it 9. So there goes that idea.
So will it be 3 times?
So what I'm going to do is cross multiply. 3 times 9? 27 equals 5 times x. And now we're in chapter 4, solving equations. That's chapter 4 last time. If you have multiplication, what is the opposite to multiplications?
Division.
Divide. I need to make that 1, so I'm going to divide this side by what? By 5. X will have to be what? 27/5. So it's not even a whole number. If you want these two to be proportional, equal to each other, I need to make sure x has a value of 27/5.
Is that how they're going to want it, though, or they're going to want the decimal?
They probably leave it like that. It depends. They'll tell you. They'll tell you the improper fraction, mixed number, decimal. If they want it improper fraction, I mean mixed number, that's improper. If they want it mixed number, you go 27 divided by 5. 5 times 5 is 25. What's the remainder? 2. So it'll be 5 and 2 over 5. If they want it as a decimal number, you go up, there's a decimal point here. There's a lot of zeros here. Bring that 0 down. 20 divided by 5? 4. 4 times 5? That's 5.4. So any one of them is a correct answer. Yes, yes, and yes. It depends which way they want it. But you can see now why we studied solving equations last class. Because if we didn't cover that when we get to this point, how would I solve this one? So let me try more problems with these. Then we'll show you where we use these in real life. (840 over 4) equals x over 10. Solve for x. Cross multiply. 840 times 10. 4 times x. I got to divide by what now? By 4. X equals, let me go to the side and divide. Well, 8 by 4 is what? 2. 4 by 4, 1. Should be 2100 if you divide them. The unknown does not have to be on the top alone. I could have 9 over 12 equals 6 over x. Solve it. So my unknown could be anywhere. Could be in the first one, the second one, top, bottom, it doesn't matter. Cross multiply. 9x equals. Is that 72? Mm-hmm. And to solve for x, we're going to divide by what? 9. By 9. Try again. 8. Ready to try one? You know I'm always mean. X over 96 equals 1/4 over 12. So we're going to cross multiply. I can't wait to finish because the camera is running. Later I'll let you, once I shut the camera, I'll let you take as much time as you want. So x times 12, which is what? 12x equals. I got to multiply 96 by 1/4. Go to the side. 96 times, that's over 1, very good, times 1 over 4.
4 divided by
So 96 into 4, which is what?
24.
24.
Divide by 12.
Now to solve for x, we're going to divide by 12. X equals 2. X equals 2. How do we use proportion? Where do we use them? I can tell you actually this summer, when I say I got sucked into this, that was definitely I got sucked into doing this grant. We have a project, it's called STEM Academy. I was wearing a t-shirt that says STEM Academy we got from them. And as we have new kids who are coming to us, just finished high school, we try to teach them about science, encourage them to go into science. And one of the things I did with the class, we met in this room, I gave each group a yardstick and said, let's go outside. We went on the green on a beautiful day, and I said, I want you to tell me how tall this tree, and you can't climb it. And I gave them a yardstick. So there's a tree, I want to know how tall that tree, what's the height of the tree? Without climbing it. What is that height? And I said, think about it. Do anything you want to do. Huh? All they had is a yardstick with them.
Put them all together.
Yeah.
That's what I would do.
Good idea, but it wasn't enough, I can tell you, because the trees are big. And you can't climb the tree.
I would have quit.
You can train some animal to climb, put marks there, and a smart animal.
Squirrel.
Yep.
Guess.
No guessing. I'll add to that, there's a beautiful sunny day it was.
The
There's-
shadow.
Good, there's a shadow of the tree. Here is the shadow. Okay, there's the shadow. We measure the length of the shadow. I'll give you that. Let's say that shadow was 25 feet. It depends what time you do it. If you go at noon, there's a shadow is not much. If you go, the class starts at 2, ends at 4, so in the afternoon, the sun is down, the shadow is really long. So 25 feet, the shadow. How is that going to help me?
Times,
The first group I dealt with, the student name was Leah. I said, Leah, come here. Here's Leah. Here. I said, Leah, how tall are you? She goes, I'm 5 feet. I'm 5 feet tall. She's short. So here's Leah's shadow. Let's say the shadow of Leah is 3.
you'd have to add some more things.
If we do them at the same time, there is a proportion. The height of Leah to her shadow should be the same as the height of the tree to its shadow. So height to shadow. So that's what we did. You could have a shadow to height. It will work too. So we said Leah's height was 5 feet. Her shadow was what? 3. The tree's height is unknown. Its shadow was what? 25. Cross multiply. 25 times 5, which is what? 125. 3 times h?
3H.
3h. So how do you find the height?
Divide by 3.
Divide by 3. 41 2/3. If you divide them. That tree was 41 2/3 feet, almost 42 feet high. We don't have to climb trees. I don't have to worry about Leah falling, breaking a bone. Leah was my guinea pig. Every time we did something, she was my practice one. She weighed about 80 pounds. We built a bridge. Leah, you're the first one to walk on it to make sure it's stable. Once she walked on it, it was safe. I go, okay, next one. But Leah was always the first one. But that's one example of proportion. We call these similar triangles. You can make a triangle out of that, you know. But I don't know why we just deal with similar triangle, because you can deal with any shape. The height to the shadow. By the way, if you did the reverse, if you did shadow to shadow, or height to height, notice what will happen if I took the height of the big to the height of the little, to Leah, I mean. Height of the tree to Leah's height, it should be the same as what? The shadow of the tree to Leah's shadow. Would I get the same answer? 3h equals what? 125? What's h equal to? 41 and 2/3. So it doesn't really matter which way you set it up, as long as you're consistent. If I do this side here, the left side is Leah's height to her shadow, then this side has to be the height of the tree to its shadow. Don't reverse them. Another example where we use this. Let's look at the New England Patriots. Sports. They won 4 games and they lost 2. So far, their win to the total is what? The ratio, it's 4-6.
Oh yeah, we had a question on that one.
If they keep the same pace, it's going to be a funny number, because 4-6 is what? 0.66666667, so it won't be a whole number. But if we keep the same pace, and let's include the first 2 playoff games just to make sure the numbers work out. 18 games. I know they play 16 games, but I'm going to include 2 playoff games. How many total wins we should expect at this pace? This is the number of games they won to the total number. Cross multiply. 4 times 18. So to solve for x, we're going to divide by what? 6. 72 divided by 6, which is what? We expect to see 12 games out of 18. It's supposed to win 12. I'll do a cooking example. I like to cook. Let's say your friend had a little gathering, and she said, hey, can you cook a meal for us? I'll pay you. And you say, okay, how many are coming? Say, I don't know. We got 16 people. So, okay, what do you want? So, you know what? Last time I was at your house, you made prime rib and it was really yummy. Can you cook prime rib for us? Okay. So you won, you got 12 pounds of prime rib for the 16 people. And you cooked it. Everyone loved it. Go, oh, this is good. You should start your own business. You should be doing catering. And your friend goes, you know what? I'm getting married in 6 months. How about you do my wedding? Okay. Well, how many people are going to be there? Well, I'm inviting 200 people. That's okay. 200 people? I can do that. The question for you is, how many pounds of meat you're going to need for these 200 people? Because you're going to go buy it. You can set up proportion for that. You go the first time you cooked, let's put pounds on the top, how many pounds of meat to the number of people. That's how I'm going to set up my proportion that way. I can set it any way I want to. For the first time I cooked, what was how many pounds? 12 to 16. If you want to keep the same proportion, it should be x to what? 200. Cross multiply. 12 times 200, which is what? 2400 equals 16x. To solve for x, we're going to divide both sides by what? 16. So what's 2400 over 16? Yep, you're right. So you will have to get 150 pounds of prime rib if you want to feed these 200 people. You can use it for traveling. Just throwing some examples off the top of my head. What does that mean for traveling? You want to travel from Springfield, Mass. Beautiful downtown Springfield to Orlando, Florida. Distance roughly from Springfield to Orlando, I think it's about 2,200 miles. You're going to drive it. Is it 22 or 1,200? 22, I think. Let me see. I think maybe 1,200, I'm sorry. Yeah, about 1,200 miles, not 22. Uh-oh. Thank you. Let's say 1,200 miles. Now, on the first day, you drove to Washington, D.C. which is about 400 miles. And the way the traffic was moving, let's give you some funky numbers so you don't guess on it quickly. Otherwise, you'll be able to guess. It took you 9.5 hours to get there. Now you're in Washington, D.C. You decide you're going to stay over. You've been driving a lot. The kids drove you nuts in the back seat. You go, enough is enough. Let's pull over. We'll stay tonight. We'll get up in the morning, finish the trip. How long, at this rate, if you stay at this rate, assuming the speed's going to stay the same, the construction is going to stay the same, the traffic pattern is the same, how long would it take to finish the trip? To finish the trip.
From Washington.
Yep. At the same pace. We can set up proportions. You can guess on this. You can see it and guess on it, right? Let's just modify just a hair. Instead of 400, because you can see that this, what's left, is twice that number. I don't want you to guess on it. Let's say this distance is 360 miles. So you can't really guess on it like boom, like that. You have to do some math. We can set a proportion. I can say distance on the top and hours on the bottom. For the first leg of the trip, what was the distance? 360. And how long it took you? To finish the trip, how many more miles you have to drive? You know, we know how many. Not X. Nope, to finish it. Right. To finish it, that's the finish. Additional.
840.
Yep, 840. And how many hours is it going to take? Yep. So I'm saying, how long would it take to finish that trip? Not from start to finish, from Washington, D.C. to Orlando. From Washington to Orlando, you still have 840 miles. So now cross multiply. 360 times X.
360x.
840 times 9.5. 7980. To solve for X now, we're going to divide by what?
360.
360. And notice I can make my life easy by canceling the zeros there. X equals 798 divided by 36. And if you do the math, there's your decimal point, 79836. My decimal point is here, lots of zeros if I need them. 79 by 36 is 2. 2 times 36 is what? 72? $58.
What?
Not 58. What is that number?
78.
78. I better get another one, huh?
That's what you said.
Yeah, you said, oh, I don't plan on making any mistakes.
I lied again. 78. That's another 2. 72. Now bring that 60 here. That's 1. 6 from 10, which is what? 4. 3 from 5, 1. 140. Could that be 6? 6 times 6, 36. 6 times 3, 18. 18 and 3 is what? 21? Oh no, that's too high.
18. Yeah, you're right. 21.
3 from 5, that should be 2. Was that 240 here? Not a 140, 240 I think.
What?
6 from 10
Yeah.
is 4. 3 from 5 is 2. That's 240. I wrote 140 here. So 6 times 3, 18. 18, 3 is 21. 6 from 10 again, which is what?
See that.
Yeah.
Oh, okay.
6 from 10. 1 from 3, because that's 3 now. 2. Bring that number. Oh, what do you know? It's 240 again, right? So what is it going to be? Repeating?
Yeah, 22 points. Wait, do you round that though, or only if they ask you?
Well, if it says approximately, you go, okay, 22 point nearest 10th 2, or if you want the correct answer, you go 22.16 with the bar over the 6. But you still have 20.
Round it to the nearest hundred, so it'd be like 22.17.
You can. Depends what they want it. You know?
They'll ask. Yeah.
Yep. But you're still talking about 22 more hours. Because if you think about it, 360 miles at 9.5 hours, you weren't going that fast. What's 360? 360 divided by 9.5. You were going at 38 miles per hour. So it's going to take you a long time to make it to Orlando.
Oh my gosh.
Maybe construction. Maybe it was a big holiday, traffic. Or night traveling. Night traveling is always a nightmare. So that's an application also where we use proportion. You can use proportion in wildlife estimation. This is what the government does. Anyone lives in Springfield?
Yes.
Lake Lorraine. You know that Indian Orchard? Let's say we want to know how many fish in Lake Lorraine, Indian Orchard. Never been to it, but I know there's a Lake Lorraine there. We want to know how many fish in Lake Lorraine. So this is Lake Lorraine Indian Orchard. We have a few little fishes in it. Here we go. These are fish in the lake. We're trying to estimate how many fish in the lake. So the total number unknown to us. The way we do that, the way the government does that, we actually send people out there and says, why don't you go fishing there? And whatever fish they grab, and we put them in different spots. We might put a person here, a person there, a person here, somewhere in the middle. We have people all over. We say, go catch as many fish as you can, tag them and release them. So here we go. These are the total number of fish. The total of them that we tagged. Tagged, let's say 20 fish that day. Then we let them go. Assuming nothing happened to change that environment, meaning what? Nobody came in, dumped a truckload of gasoline in that water there. Or we didn't have a fishing derby 2 nights after that. If nothing changes, we want to know how many fish in Lake Lorraine. So we wait about 2-3 weeks. We go back, and on the second trip, let's say the total now that we caught that day is 30 fish.
Tagged 30 or?
All together. And out of those 30 we caught, let's say there were only 4 of them were tagged. 4. We can estimate now how many fish live in the lake. We can set up a ratio of total to tag. On the first day, when we went there, do we know how many fish live in the lake? No. Do you know how many were tagged on that day? 20. If nothing happens to change that on the second trip, how many fish altogether? And how many were tagged? Cross, multiply, and solve. X times 4.
4x.
20 times 30. And to solve for x, what do we do? There are 150 fish in Lake Lorraine. 150 good sized fish, not minnows, the ones we can catch. That's how the government estimates how many animals out there. We want to know how many bald eagles, Alaska. That's what we do. You want to know how many red foxes in Wilbraham. That's how they do it. Because you can't count them. There's no way you can go there. How many grizzly bears in Alaska again? We go there, we grab a few of them, tag them, shoot them, tag them, release them. Then we repeat the process. And we see out of that at the end how many we have there.
Do you do the same thing with population?
Yeah, we can do population that way, exactly. Yep. Okay, let's